Mr. McClinton, I got the lowest grade on my math.
1.
On my ACT.
1?
No. That's the lowest grade overall on my thing. Like, I had everything else higher on my ACT.
Anyone know what banks are at?
Oh, like on my math portion? Yeah, I got it.
The difference between a 14 and a 19 on the math is 4 to 8 questions.
That's wild.
So if you get 4 to 8 more right, it'll bump it to a 19.
If I would have got 4 of those questions, the I questions that I saw, I would have done.
Yep. So when y'all take it in the spring, you'll be able to improve it. You'll do better because we'll have covered more of the Algebra 2 material. You'll be more ready for it. And for, I think most of y'all, that was the first time you took the full ACT, yes? So you'll be a little more comfortable with taking the test because the test itself is a little daunting if you haven't taken it before. Questions on the homework? Questions on the homework assignments? All right, guys. So far, the ways that we have learned for solving quadratics, the first one we went over was factoring. So when we factor quadratics, we get them into 2 sets of parentheses being multiplied together. Yep. 2 parentheses multiplied together equals 0. One of them must be 0. We set them equal to 0 and solve. The second method for solving was graphing. We plugged it into the graphing calculator and saw where it crossed the x-axis. We were trying to find out what values of x will make the y value be 0. Our third method was the square root method. And these 3 methods we went over, and they work in a lot of different cases, but they don't work every single time. The first one that worked every single time was completing the square. Completing the square was the first method that we went over that can solve any and all quadratics, and we went over it yesterday. We went over the steps for it. Now today we're going over the other method that works every single time, and we call it the quadratic formula. The quadratic formula will solve any and all quadratics, and that's the method we're going to look at today. Now the quadratic formula itself is this right here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And to use this, we plug in the values of a, b, and c of a quadratic equation that is set equal to 0, and then simplify. So, yes. So our first one that we're looking at, we're going to look at this one here. Now, before we can plug it into the calculator, we need this equal to 0. What is the first thing we need to do to make this equation equal 0?
Subtract 5. No,
Subtract 5.
and then add it.
Because if we subtracted the 3x, we would also have to move the x squared over. We'd have to do 2 steps. Now, by subtracting 5, we get x squared plus 3x minus 5. For the most part, I would use the 30xs for this. We get this here. Now, the formula itself, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to know what the value of a, b, and c is. So looking at this equation, x squared plus 3x minus 5, because this is matching up with our ax squared plus bx plus c equals 0. So So that would be for completing the square. We don't have to find C or make a perfect square trinomial. So what is the value of A? A is in front of x squared, so A is 1. The value of B is, and the value of C is -5. Question on how we found the values of A, B, and C. So now we're going to plug it in. So we have negative B, so it'd be -3 plus or minus the square root of. So the first thing we have inside the radical is B squared. So we don't do the plus or minus. So we won't plug the whole thing in. We'll do it part by part. We'll get there. No calculator for now, because we're going to plug each one in. So we have our 3 squared minus 4 times A. Well, A is times C, which is -5. All over 2A. Well, A in our case is 1. So I've gone into this formula and plugged in the values of A, B, and C in their corresponding spots. Questions on this so far? Now we're going to do some simplifying. Our -3 is, well, just -3. Our 2 times 1 is 2. Now I'm not going to plug the square root in. I'm going to take everything inside the radical first. So we have 3 squared minus 4 times 1 times -5. So on the 30XS, the yellow calculator, we have 3 squared minus 4 times 1 times -5. I'm going to type it in exactly as we have it. We enter, we get 29. So I typed the whole thing in, we get 29, yes? And we can plug it in there, because the 3 squared minus 4 times 1 times 5, that whole thing became 29. So it's telling us we have -3 plus or minus the square root of 29 over 2. Questions on how we got to this point here? Now we need to see if we can reduce the square root of 29. Square root of 29 is square root of 29. It doesn't simplify. That's the final answer. Questions on this here? We ready for the next one? 3x squared plus 4x equals 10. So the first thing we need to do is get this equal to, how can we do that? Telling us 3x squared plus 4x minus 10 is equal to 0. A, B, C. So in our case here, what's the value of A? Value of B, C, -10. Because we will always take the sign in front of the number. Now our formula is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. -b, so -4 plus or minus the square root of b squared, so 4 squared minus 4 times a, which is, times c, which is all over 2 times a, so we have 2 times 3. Now we can do some simplifying. Our -4 is just, well, -4. Our 2 times 3 in the denominator is, and now we need to simplify what's inside the radical. Our 4 squared minus 4 times 3 times -10. 4 squared minus 4 times 3 times negative 10 is 136. Well, we can, because we will end up taking the square root of 136, which is 2 squared root of 34. We will. Now, the reason I don't do it all at once is because the 30xs will simplify radicals, as long as what's inside the radical is not what? Negative. Because if what's inside the radical is negative, we have our imaginary numbers, it's going to throw it out. And if it throws it out, it means I have to retype the whole thing in without the radical to see what it is. So sometimes it's a little bit easier to type it in and see that, well, in this case, it is still a positive number, so we can take the square root of it in the calculator and get 2 square root of 34 over 6. So it does reduce. If it was negative, we would take the I out, take the radical of it, and then go from there. Questions on this here? Is there a like term between our two numbers in the numerator and the denominator? 2. We'll need to simplify that 2 out. Now there's different ways we can do it. One is, since they all have that common factor of 2 in them, we can divide each term by 2 to reduce it. Because the denominator would become, the negative 4 would become negative 2, plus or minus our 2 squared root of 34 would become just the square root of 34. We pulled the 2 out of all 3 terms. We could put 1, but we don't have to write it because we have the square root of 34. If it had just been 2, then we would have. Now what is interesting, we could do this in the 30xs, negative 4 plus square root 2 square root of 34 over 6. It does flip it. It puts the 34 first, but we still get the same thing. It will reduce it for us. Now we could do the same thing and say negative 4 minus 2 square root of 34 over 6. And it just tells us we have the negative version of it. For the most part, I will take either one of these. I would prefer if you could get it in simplest form, but negative 4 plus or minus 2 square root of 34 over 6 is also acceptable. For me, anyways. Questions on this here? Any questions on anything we've done so far? Let's look at the next one. X squared minus 6x plus 4 equals 0. What's the first thing we need to do to get this equation to be 0? Nothing. It's already 0. A, B, and C. A is, B is, and C is 4. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we plug in b, it'd be negative 6 plus or minus the square root of negative 6 squared, 4 times 1 times 4 all over 2a, which is 2 times 1. Now our negative 6 is positive 6. 2 times 1 is just 2. Now we could type the radical and everything in the 30xs, or we can do parentheses. Negative 6 squared minus 4 times 1 times 4, which is 20. Now you will need to put the parentheses around the negative 6 Otherwise, it will give you a completely different answer. Now we do need to see if we can take the square root of 20. 30xs will let us do this. Second square root of 20 is questions on how we got to this point here. Is our 6, 2 squared of 5, 6 and 2 squared of 5 divisible by our denominator of 2? Yep, they both are. We could try and check this in the calculator and say 6 plus 2 square root of 5 all over 2, and we get square root of 5 plus 3, or 3 plus the square root of 5. Because if we try the negative case, it says that the 5 is, square root of 5 is positive and negative. So x is equal to 3 plus or minus the square root of 5. If that like term is not all the way across, if it had just been 6 plus or minus the square root of 5 all over 2, we'd have left it, because it has to be divisible by both. Questions on this here? We ready for the next one? 2x squared plus 4 equals negative 7. What can we do to make this thing equal 0? Which would give us 2x squared plus 7x plus 4 is equal to 0. A is, B is, C is, D is. There's not one. Negative b plus or minus square root of b squared minus 4ac all over 2a. Well, now we just need to plug in our values. So negative b would be negative 7 plus or minus the square root of 7 squared minus 4 times a, which is 2, times c, which is 4, all over 2 times a, or 2 times 2. Our negative 7 is negative 7. Our 2 times 2 is 4. Questions on how we got to this point here? Now, we need to plug it in. 7 squared minus 4 times 2 times, what's it, 4? I don't know. Yeah. 4, which gives us, and if we take the square root of 17, we get just 17. So that's it. We can't reduce it any further than that without turning it into decimals, and we want to keep it as fractional. Maybe. Questions on this here? Any questions on any of this so far? Which one do we like better, completing the square or quadratic formula? Yeah, normally that's the way it goes. Yes. We need to get this equal to, so what do we need to do? We just need to move it over. We just need to get this equal to 0. Completing the square, we would need the a value to be 1. But with the quadratic formula, we just need it equal to 0. Our value of a is negative 5. our value of B is, value of C is. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Well, our B value in this case is 1. So we have negative 1 plus or minus 1 squared times 4 minus 4 times A, which is negative 5 times C, which is 8, all over 2 times negative 5. Now our negative B is negative 1. 2 times negative 5 is negative 10. Now we need to see what's inside the radical. Our 1 squared minus 4 times negative 5 times 8. 1 squared minus 4 times negative 5 times 8 is 161. So 1 squared minus 4 times negative 5 times 8.
Oh.
Because B is
I
1.
put 8 and
Yep. Switched B and C.
I just didn't.
Yep.
I'll probably look at B and then put 8.
Yes.
I don't know why I would have to put 1 on B first.
Yes.
Anyway.
So sometimes, again, especially on this here for the test, I would write it out each step. That way, I'll see that it's a calculator error, not an actual solving error. So the square root of 161 does not simplify. We do have this here. There is one simplification that we need to do, and it involves this negative with the 10. And what we're going to do is move it to the numerator and apply it to everything on top of the fraction. Because when we apply it to the entire numerator, we're changing the signs of the entire numerator. So instead of negative 1, we have positive 1. We'll still have the square root of 161 because that didn't simplify. But the plus or minus. Well, the plus in this case is going to become minus. And the minus is going to become plus. So the positive case became negative and the negative case became positive. Plus and minus, which ends up giving us plus and minus. It's kind of odd that it works that way, but it does nicely work that way. So we really end up just changing the sign.
So does the number in front of the 161, does the number like the 2?
It would have still flipped just the plus and minus. Because the 2 is positive and negative. The positive 2 would have become negative 2, and the negative 2 would have become positive 2.
So we're just basically.
Yep. The other way we could have done this and avoided that whole thing was I could have changed the signs here. I'll show you guys this here. Well, let's use, I'm going to use a crayon. Red crayon. Because if we, what we would have done is just divided everything. Okay, we're not using a crayon. Because that just got way too messy. Actually, we'll just use this color. What I could have done is divided everything by negative 1, which would have made this positive 5, negative 1, and negative 8, which would have meant a negative here, plus, negative, plus. So the 10 would have become positive 10. The negative, negative 1 made this plus 1.
So how would we
if A is negative, just make it, divide everything by that negative 1, and it'll make it all. It'll make A positive. Now what's interesting, inside here, still comes out to 161.
Okay, so if we have to move the negative, so if we have to move the A and it becomes negative, we're just going to flip the sign to the other things too.
We can divide everything by negative 1, flip the signs.
That's
Yeah.
easier to do instead of waiting to the end.
Yes, but it gives us the same answer. Questions on anything we've done so far? So just like with the last one, if we can keep A positive, it makes things a little bit nicer. So here, we have 25x squared minus 8x equals 12x minus 4. So the first thing I can do is subtract 12x, which tells us 25x squared minus 20x is equal to negative 4. Next thing we can do is add 4, telling us 25x squared minus 20x plus 4 is equal to 0. Questions on how we got this equal to 0? Yes. We feel good with getting the equation equal to 0. Value of A is value of B, value of C. Now we can plug this in, negative B. Well, our value B is negative 20. Plus or minus negative 20 squared, B squared. Minus 4, A is 25 and C is 4, all over 2A. 2 times 25. Now our negative 20 is just going to be 20. Huh? Yeah. 2 times 25 is 50. Now when we plug negative 20 squared minus 4 times 25 times 4 in the calculator, it does indeed come out to be 0. Now what's the square root of 0? Yeah, because we're asking what times itself is 0. Well, that would be 0. What is 20 plus 0? What's 20 minus 0? So do we even need the 0? Which really just tells us this is 20 over, will that reduce?
Oh, yeah, well,
Because they both have a common factor of 10.
we've been doing reducing, I'm always like,
Because the nice one is, yep, but that's it, it's 2/5. Questions on any of this here? We ready for the next one? We ready for the next one? Negative x squared plus 4x equals 13. What can we do first to get this equal to 0? I would subtract the 13 because we could subtract the 4x and then add the x squared.
Oh, do that negative.
Exactly. Since A is negative, and we saw in the last one, it kind of made things a little bit interesting at the end. We can divide the whole thing by negative 1. Or we can multiply the whole thing by negative 1. It will get us to the same spot because our negative x squared divided by negative 1 is positive, x squared. Our 4x divided by negative 1 is negative 4x. And our negative 13 divided by negative 1 is 13. A is, B is, C is. X is equal to negative b, so we'd have negative 4 plus or minus square root of negative 4 squared minus 4 times a times c, 4 times 1 times 13, all over 2 times a. Well, our negative 4 is 4, plus or minus 1 times 2 is 2. Now when we type negative 4 squared minus 4 times 1 times 13, we get negative 36. So this here would be the case where we couldn't type the square root of negative 4 squared plus minus 4 times 1 times 13 into the calculator, because it would throw out an error, because we can't have the square root of a negative. But we can still take it, because the negative comes out as, and then we can take the square root of 36, which is 6, so it is 6i. Questions on this here? Now, the graphing calculator can be handy like the other ones were with simplifying. Clear that out. Because we can go alpha y equals enter. Because we had 4 plus 6i all over 2, yes? Now you can see, you can let the calculator simplify it for me. So we have 2 plus 3i. But we also have the negative case, so we're really saying 2 plus or minus 3i. Because since both the 4 and 6 were divisible by 2, we really divided both by 2, getting us 2 plus or minus 3i. So the negative case inside the radical is no different than the positive case. We just take the negative out as I, simplify the radical, and then go from there. Questions on this here? Yes. Questions on any of this here? So, now the discriminant, this is the last part of this lesson, is the b squared minus 4ac. It's what's inside the radical. Yes. Now, the discriminant tells us one of 3 things. Well, it actually tells us 2 things. One tells us the number of solutions we can have. It's either going to be 2 or 1. If b squared minus 4ac is greater than 0, we have 2 solutions. And they're both real solutions. So b squared minus 4ac is greater than 0. We have 2 real solutions. If b squared minus 4ac is equal to 0, we saw that a minute ago, we have 1 real solution, because we ended up getting 2/5. And if b squared minus 4ac is less than 0, like we saw was negative 36, we have 2 complex solutions. We have 2 imaginary solutions. We get I. So the discriminant, this b squared minus 4ac, will tell us how many solutions we'll have, either 1 or 2, and what type of solutions we'll have, either real or complex. So if we look at this first one here, x squared minus 6x plus 10. A, B, and C. Well, A in our case is, B is, and C is 10. So we want to see what b squared minus 4ac is. So this would be negative 6 squared minus 4 times 1 times 10. Negative 6 squared minus 4 times 1 times 10 is negative 4. So the value of the discriminant is negative 4. So that is the first part, and that would be the first part of your answer on the homework. Now, since it's less than 0, we do have two solutions, and they would be complex solutions. So since the discriminant is negative, it's less than 0, we have two complex solutions. That's it. Yeah. Because the value of the discriminant, our b squared minus 4ac, is -4. And in the quadratic formula, we take the square root of it. Well, the square root of a negative would cause I to come out. I is our imaginary, our complex. So we would have two complex solutions. The plus or minus gives us the 2. Because we'd have the positive and negative case of, in this case, 2i. If it comes out as a negative, we would have two complex. Let's look at the next one. Well, a is 1, b is still -6, but c in this case is 9. b squared minus 4ac, we're going to plug in -6 again, 1 in, and this time 9. So it is if it's equal to 0, we will have one real solution. And we had that earlier because we saw that the discriminant was 0, square root of it was still 0, because we had 20 plus or minus 0 over 50, which just gave us 2/5. We only had one answer. Really, we could say one unique 0. There are still two, but like with 2/5, it's just 2/5 and 2/5. We only really have one. And the last one. This time, A is still 1, B is still -6, but this time C is 8. If we plug this whole thing into the calculator, we get 4. Well, this time it is greater than 0. Yes, positive. So we will have two real solutions. And that's it. Imaginary would be the other. But I will take complex or imaginary, either one. Questions on this here? So the 6 through 16 even, you're solving. You're actually finding the values of x that make the function equal 0. 6 through 16 even. 21 through 24, you're finding the value of the discriminant, how many solutions, which is either 2 or 1, and the type, real or complex.